Okay, welcome back from Christmas break. Today is Tuesday, January 7th. We're halfway done of our year, which is hard to believe. We're almost halfway, which means the learning that we've acquired so far is learning that you should have been fairly fluent in, and these questions are all questions that we've done this year. So the first question you have is an integer bed mass question, and it says negative 10 plus 4 minus negative 6. Now, when we did this question on the test, I gave you marks for showing your work properly and for getting the correct answer. So in order to show your work properly, you have to simplify one step at a time and rewrite that new simplified step underneath the original. So negative 10 plus 4 is negative 6. And then the rest of it, I simply write down underneath it. Okay, so when I simplify the first one, negative 10 plus 4, 10 negatives plus 4 positives. What do I have more of? I have more negatives, so it's negative 6. And now that I have subtraction, if I say negative 6, take away negative 6, you will get 0, because if I have negative 6 and I take away negative 6, I'll be left with nothing. Or if you use the addition of the opposite second integer, 6 negatives combined with 6 positives will still give you 0. So either way, your answer is 0 for that question. Question 2 says negative 5 bracket negative 2, and for some of you, you've forgotten what this means. And negative 5 bracket negative 2 is the same thing as saying negative 5 times negative 2. When a number is next to another number in brackets, it means multiplication. So negative 5 times negative 2 is a positive 10, because negative times negative is a positive. And I write the rest of it down. Now we have an addition statement, positive 10 plus negative 12. What do I have more of? I have more negatives. How many more? 2. So your answer is negative 2. Now you don't need to have the positive symbol there. You can just have 10 plus negative 12. Question 3, 10 plus 3 multiplied by negative 10. So the first thing I'm going to do is do the 3 times negative 10. And 3 times negative 10 is negative 30. So if I put negative 30 down without brackets, it has a plus minus, and that doesn't look right. So what we do is we always keep our integer symbol in brackets to separate it from our operational sign of addition. So we should have 10 plus and negative 30 in brackets. I have more negatives. I have 20 more negatives, and therefore 10 plus negative 30 is negative 20. Next question says negative 1 multiplied by 10 take away 15 plus 4 divided by negative 2. First thing I'm going to do is my brackets in bed mass. So what is 10 take away 15? It's negative 5, not positive 5, because 10 take away 10 is 0, 10 take away 11 is negative 1, etc. And the rest just simply comes down. Now I have a multiplication, an addition, and a division. And some people think that because bed mass has a D before an M, you're supposed to do division first, but that's not true. Division multiplication is one step in the order they appear from left to right. So of the division multiplication, I have multiplication first. Negative 1 times 5 is positive 5. And then 5 plus 4 divided by negative 2 is negative 2. And finally, 5 plus negative 2 is positive 3. Your next question starts to transition into fraction bed mass questions. And here we have 1/5 plus 2/3 times 4. So obviously the first thing we need to do is our multiplication. And the difficult part for some students is realizing that with multiplication, so the first thing you need to do, of course, is the multiplication. And most people forget that when you are multiplying by a whole number, like 4, 4 is really the same thing as being 4 over 1. And when you multiply fractions, you do not need common denominators. You simply multiply your numerators and multiply your denominators to get the answer of 8/3. So 2/3 multiplied by 4 is 8/3. And when you transition from multiplication to addition, addition does require you to have common denominators. So we're going to write down 15 and equivalent fractions. So 3/15 is equivalent to 1/5. And 40/15 is equivalent to 8/3. And now that you have that, you can add your numerators and keep your denominator, which gives you an answer of 43/15. Now that's an improper fraction, and you've been told numerous times that if you have an improper fraction as an answer, your job is to reconfigure it to be a mixed fraction. So 2/15 is 30, which means there's 13 left over to get to 43. And your final answer as a mixed fraction is 2 13/15. Your next question is almost identical to the last one, except we have 2/5 plus 3/4 divided by 2. So I'm going to do my division first, which means over here, 3/4 divided by 2 over 1 is the same thing as we learned that we can take the first fraction, change the operation to multiplication, and use what we call the reciprocal of the second fraction to get the same answer. So when we are dividing fractions, we can change it to multiplication, use the reciprocal. And in this case, when we multiply the numerators and denominators, we get 3/8. So 3/4 divided by 2 is 3/8. Now we find common denominators. Now we find equivalent fractions, because if I multiply this by 8 and this by 8, I get 16/40. Multiply this by 5 and this by 5, I create an equivalent fraction of 15/40. Add the numerators, keep your denominator. Your final answer is 31/40. Next question, same type of thing, except this time we have mixed fractions. So what I always like to do, and you don't have to do it, but I like to do it, I like to change everything the improper first. Makes it a lot neater and easier to work with. Now that we have that, we can do our multiplication first. So 4/3 plus, not 15, 14/18, or if you wanted to, you can go 4/3 plus 7/9, because you could reduce your 14/18 to lowest terms if you wanted to. You don't have to. Either way you do it, your common denominator is actually 27. Oh, sorry, no, it's not. Did I make a mistake there? 18, sorry, it is 18. My fault. It's 18. So 14/18 will stay 14/18. Your other fraction will become 24/18. Now that you have that, you can add your numerators to get 38. Keep your denominator to get 18, which will be 2 and 2/18, or 2 and 1/9. If you actually used the lowest terms, you would have done 9 as your common denominator, and you would have made 12 here. You would end with 21/9. Did I make a mistake somewhere? Where is it? "12 plus 7 is 19, not 21. That's right. And then we would have 2 and 2 and 1/9 as your answer. Okay, we got there a little bit. Okay. Your next question says 2 multiplied by 3/8 take away 1/10. So again, we're going to do our multiplication first. And when you have whole numbers, it's always easiest to remember that 2 is the same thing as 2 over 1. And the reason why we want to write that is because now we multiply the numerators to get 6, multiply the denominators to get 8. And I end up with 6/8 take away 1/10. You could reduce that down to lowest terms of 3/4 take away 1/10. Both will work. And when you do that, your common denominator will be 40, your lowest common denominator. You could use 80 as well. It's not going to kill you. If you used 80, it's fine. But we're going to make our equivalent fractions. So an equivalent fraction to 6/8 is 30/40. An equivalent fraction to 1/10 is 4/40. 30/40 take away 4/40 is 26/40, which is 13/20 in lowest terms. Yeah. So in lowest terms, it's 13/20. And now we get to the meat and bones of what we were working on for the last month and a half, which is your algebra. So the first algebra question says a number take away 4 is equal to -10. Now all of these questions you were asked to solve by opposite operation. So -4 is your constant. And even though there isn't one, 1, because it's 1x, 1 is your coefficient. It's not that there isn't a coefficient, there is a 1, but we don't write it. So because we really don't have to worry about 1 coefficients, we just have a constant. And in order to get rid of the constant, we're going to apply the opposite to both sides. So instead of saying subtract 4 from both sides, we're going to add 4. That's going to create a 0 pair, leaving me with x. Negative 10 and a positive 4. There's more negatives. How many more? 6. So your answer is x equals negative 6. Now remember, if I was to draw this, I would have x on one side and a negative 4 equals negative 10. I would have taken this and added 4 positives to both sides. And when I did so, I would have x is equal to negative 6 as well. Your next question, this time the difference between the last question and this question is not a whole lot, because 4 is your constant, and this, however, is negative x, and a negative x actually is the same thing as a negative 1x, so therefore the coefficient, even though it's not written, is a negative 1. And we're going to see that as we go through opposite operation. So the first thing I want to do is get rid of my constant by subtracting 4 from both sides. That does leave me with a negative x, not a positive x, but a negative x equals negative 14. And keeping in mind, a negative x is the same thing as a negative 1x, and negative 1 is your coefficient. I would then have to divide both sides by negative 1 to get rid of that coefficient. So I want to employ, since negative 1 times x, the opposite of dividing by negative 1, x would equal a positive 14, not a negative 14. A negative half of x. Now, sometimes people just get hung up in what it looks like and they figure about what they're supposed to do with the opposite operation. But remember, this is a negative half of x, which is the same thing as a negative half of x, or a negative half of x, or a negative half of x. All of these 4 things actually, this, and this are all the same thing. We're using this one right here because it's the most common way to express a negative half of x. But if we think about that as also being x divided by negative 2, the opposite to dividing by negative 2 is to multiply by negative 2. Those are opposite operations. And x would equal a negative 20. Our next question is negative 2x equals 10. So for this one, it's negative 2 multiplied by x. This is negative 2 multiplied by x. So the opposite of multiplying by x is dividing. So we're going to divide both sides by the coefficient, or negative 2, to get rid of the coefficient, and x will equal a positive 5, because 10 divided by 2 is 5. Negative divided by negative is a positive. Now we have two-step algebraic equations. And in a two-step algebraic equation, we have both a constant and a coefficient. And when you have both, we agreed that it's the easiest thing to get rid of first is your constant. In grade 9, you're going to see that you can get rid of the coefficient first if you want. It's easy to do that as well. But we're going to get rid of the constant first. And to do that, we're going to apply the opposite operation. And that's going to get rid of our constant. Negative 2x equals 22. So we've taken it from a two-step equation to now just a one-step equation, because now we just have the coefficient left. To get rid of that, we're going to divide both sides by negative 2. And x is going to equal negative 11. Your next question says a negative quarter of x. Now, I could have written this as a negative quarter of x plus 1 equals negative 8. These are the same questions. And if you can look at this and look at this, and see them as the same thing, then your algebra sense is evolving, because that's an important way to see both questions as being the same thing. But another thing is that when you are given this part of your expression, you needed to make sure that you understand that a negative quarter of x in all three instances are the same thing, right? And if given the opportunity to write it any of the three ways, we've agreed that putting your negative symbol in your denominator makes it simpler to isolate the variable using opposite operation. So when I do this, I'm first going to get rid of my constant, because I know that's the first thing I should do. But when I rewrite it, I am going to rewrite it like this. And that's going to make my next step easier. So now I'm going to multiply both sides by negative 4. And x will equal a positive 36. 36. In our next question, it's the exact same question almost as the last one, except our numbers are a little different. But adding 1 to get rid of the constant, it's already put the negative symbol in the denominator for you. All we have to do is multiply both sides by negative 4. And I end up with x is equal to positive 4. So a lot of these questions is just recognizing what is my constant, what is my coefficient, and what is the operation for each. And if you know that, and you do it to both sides, you're always going to be guaranteed isolating the variable correctly. Like this next question. If I ask you, what is the coefficient, what is the constant? If you know that negative 1 is the constant, and positive 3 is the coefficient, and you know you have to get rid of the constant first, then you know your first step is to add 1 to both sides. So when we add 1 to both sides, it creates a zero pair. I'm left just with my coefficient of 3x equals 9. Get rid of your coefficient by applying the opposite operation, since 3x means 3 multiplied by x. Dividing by 3 is the opposite, and x will equal a positive 3. Our next question. So now we have a 10 as a constant in this question, and a negative half as a coefficient in x. Get rid of your constant of 10 by subtracting 10 from both sides. And now that you have this, remember you keep your negative symbol in your denominator. You're going to multiply both sides by negative 2. And x will equal 32. The difference with the next question is that your variable is actually on the right-hand side, not the left. But 3 is your constant, and 4 is your coefficient. Get rid of your constant first by subtracting 3 from both sides. Negative 4 equals 4x. Get rid of your coefficient by dividing both sides by 4. And a negative 4 divided by a positive 4 is a negative 1. Your next two questions involve distributive property. And the easiest way for me to show you how to do this again, or what it's all about, is to draw it. So if we think about what x minus 10 looks like, there's x minus 10 here. And this would be x minus 10. But this 2 means we double it. So if I doubled x minus 10, two groups of x minus 10 would look like this. Is equal to negative 6. So when I ask myself, well, two groups of x minus 10, what is that really? Well, it's really two x's. And it's really negative 20. Because we have to expand it using what we call distributive property. Both the x is multiplied by 2 and the minus 10 is multiplied by 2. We now add 20 to both sides. And 2x will equal 14. And when we do that, we divide both sides by 2, and we get a final answer for x equals positive 7. Okay? Another way to do it, though, instead of doing it using expansion, is you could have actually divided both sides by 2. And if I use the drawing to figure that out, if I was to divide both of these scales equally into two different scales. Then each scale would say x minus 10 is equal to negative 3, and that makes sense because if two groups of x minus 10 equals negative 6, then each group of x minus 10 must be equal to negative 3. And what we do here is we simply divide both sides by 2. And we would end up with one group of x minus 10 is equal to negative 3. And I would add 10 to both sides and get the answer of x still equals 7, but a different way. In your next question, the only difference is now we have negative 2 groups of x minus 4. So if I was to expand it, and I say, okay, if I had 2 groups of x, it would be 2x. But if I have negative 2 groups of x, it's negative 2x. If I had 2 groups of negative 4, that would be negative 8. But if I have negative 2 groups, a negative 2 times a negative 4 is a positive 8. A lot of people probably had a negative 8 there, but it's a positive 8. Because a negative 2 times a negative 4 is a positive 8. Subtract 8 from both sides. Negative 2x equals 4. Divide both sides by your coefficient, and x will equal negative 2. Our next question is a linear relation, and you're given a table of values where there are 3 ordered pairs, a 110, a 215, and a 320. And remember, if we were to graph those without putting points down, because it's a linear relation, it would look something like this. And we know that there's an equation that shows the relationship between x and y in this table. And the way we find that equation is look for the difference in y divided by the difference in x. The difference in y divided by the difference of x is 5. And this 5 is the coefficient for x in your equation. Once you know that, you take any ordered pair and you substitute the x value, which in this case is 1, and the y value, which in this case is 10. And since 5 does not equal 10, a constant is required. And that constant is to add 5 to make it true. And therefore, this equation is the equation that matches the table of values. So for these 3 pairs that we know, this yellow equation matches it. So if that's true, then when x equals 17, we should be able to figure out, when x is 17, we should figure out what y is, but through substitution. So 5 times 17, which is your x value, plus 5 will equal my y. 5 times 17 is 85. And therefore, when x is 17, y will be 90. Your next question, I better move these over. So now your ordered pairs are 210, 422, and 634. Your difference here is adding 12. Your difference here is adding 2. 12, the difference in y, divided by the difference in x of 2, equals 6. So in my equation, 6 is your coefficient. Take your first ordered pair, or any ordered pair, and substitute it into your equation. 6 multiplied by the x value, which is 2, equals the y value, which is 10. Since 12 does not equal 10, a constant of minus 2 is required. Minus 2 is 10. So your equation is 6x minus 2 equals y. Take your 100 and insert it to where the x is. 6 times the x value of 100 minus 2 will tell me the corresponding y. Or 600 minus 2 will equal y. Or 598 will equal y. And your last linear relations question. Your equation for x and y. Your difference in the y is going down by 8. And your difference by the x is going up by 2. So the difference of y divided by the difference of x is negative 4, which is your coefficient. Take your first ordered pair, or any ordered pair, and substitute it in. X is 2, y is 8. Since negative 8 does not equal positive 8, I need to add 16 to negative 8 to get positive 8, which means that is your equation. Take 100 and substitute it in for x to get your y. And negative 384 will equal your y. The last three questions are geometry. It says, what's the area and perimeter of a square with a side length of 7? So if this is the square, and the side length is 7 meters, the area we learned is side times side, or side squared. So 7 times 7, or 7 squared, but either way you do it, you would get an area of 49 meters squared. Your perimeter is equal to 4 sides, or 4 lengths of 7, because each of these is 7 meters. So if I multiply 7 by 4, I will get 28 meters as the perimeter, or the distance around. What's the area and perimeter of this triangle? Well, area, the formula is you can either write it base times height divided by 2, or you can write it base times height divided by 2. This is the grade 7 version. This is the grade 8 version. Both the same formula. So base times height divided by 2 will be 14 multiplied by 8 divided by 2, which is 80 and 32, 112 divided by 2, which is 66 meters squared is an area. 56 meters squared. Perimeter of a triangle is simply all sides added together, or side plus side plus side, which will be 12 plus 12 plus 14, which is 38 meters for perimeter. And your last question, what's the area and perimeter of the circle? In grade 7, you learned that pi multiplied by radius is a formula, or some of your teachers taught you pi r squared. Pi times the radius, which is 8, because that's the distance from here to here, multiplied by 8, will be 3.14 multiplied by 8 equals 200.96 meters squared for area. And your last question, your perimeter, which is also the same thing as circumference, is pi multiplied by diameter, or pi multiplied by the diameter. If the radius is 8, then the diameter is 16 meters. 3.14 times 16 is 50.24. And since it's meters, that's the distance around, or the circumference or perimeter. So that is your answer.